So, I'm Nicolas Piron. I will introduce you the NixOS configuration system. So just to clarify, how many percent of you have installed NixOS? Okay, so I will... Oh, I don't know you. So I will first describe the Nix packages and all that stuff, because I guess nobody knows about it, except a few person here. So there is first a language which is called Nix, which is a functional language and which is pure, so we don't have side effects except for trace and debug stuff. We have the Nix packages, which is a collection of packages like RPM, DPKGs. And we have NixOS, which is a distribution based on this collection of packages. And the main idea with Nix is to put at the same rank segmentation fault or access to bad memory page that you don't have allocated and no such file or directory. Because if you have a reference to a file on your file system and you haven't installed it, you have a no such file or directory, and we put that as the same rank. To avoid confusing with the packager, we have a directory which is an Nix store. And in this directory, we isolate every package, so we don't have /bin and stuff like that. And we compute hash for each package in function of the sources, the libraries, the compilers, the build script, and all that stuff that are used to build the package. So if you change one of these, you should get a different hash. So you can have multiple install of OpenSSH because you have changed the build script or the compiler. Now, with OpenSSH, we have a Nix5, which is almost this one, where we have a function in Nix. We have a standard environment and a function which is called make derivation to create the package in the Nix store. We have the name of the package. We have the sources and another function to fetch the sources from your URL. And we have the command to build it. The standard environment and the function is used to include the default compiler, the enterprise tools, and numake. So this is the expression used to build OpenSSH, almost. To use this expression, we have an index file, which is all packages, and we have other index for special bird packages, for example. And in this index file, we say that OpenSSL is this one, and the lib is this one, and we use the Nix language to create this derivation. And when we evaluate OpenSSH, we evaluate the derivation, and we can instantiate it by creating a path in the Nix store. So now we have a bit of knowledge about Nix. We see that everything is isolated, and why not using such thing for other stuff? We could use this for generating configuration files. If we suppose that the configuration file we can give all its input, we can generate a configuration file for all packages. So we have done that. And we have for the system started the initRD, we have for the init script, and all the stuff which come with your distribution. And as long as you can express it in Nix, there is no problem. So we've made a distribution which is called NixOS, and this distribution you can build all static parts. Static means that we don't support databases, and every file which is mutable in such sense that we cannot produce it when we build the system. So as every package or every configuration file is isolated in the NixOS, we don't have /lib or /usr. Upgrades are non-destructive because when you install something, you install it in the store. And in the store, you have different set of packages. You can have multiple OpenSSH versions in parallel. So if you change a configuration, you can install a new version. And when you install a version, you just change a link to the versions that you want to use. So we can roll back by just using the previous version. And as we just have to change a link, upgrades are atomic. The fact that NixOS is stateless helps us to reproduce it because we have all inputs that we saw before, and we have a specific age which is determined by the inputs. So we can reproduce the same configuration. And we just have to copy the configuration to reproduce something. So here is a small example with two terms and Emacs. And you see that in /lin we only have sh because this Linux kernel requires it. But /usr is empty and /lib is empty. No, it's not empty. It does not exist. And /lib does not exist too. But we have more funny stuff. So not on my computer because my computer is too old. But you have compis, KDE stuff, players. So that's usable as a desktop. You have its size. Oh. So to show how configuration files are generated, we have SSH config, which is just a file which is stored in the NixOS. So we have a function which creates a derivation. We give the name of the configuration file, and we have statement which decide that in function of the user configuration whether we choose to enable its 11 forward or not. Nix is a lazy language, and if we don't evaluate everything, if we don't evaluate this configuration file, we won't evaluate and we won't serialize this information. We won't evaluate its alt. So we won't install it because it is not required. And there is one special thing is that when you enable its on forward, then your SSH config will depend on this program. So it depends on this hash with this package. It depends on this package. So by installing the configuration, you implicitly install its dependencies. So when you install the configuration, you install all programs that are required to run your configuration. So you don't have to first install the program and then find out how to configure it. And the generated file is what we see at this h file, and we have all forward its and ends, forward its 11 and the path to the program. So we will go further in the configuration, and in NixOS we have a main configuration which is placed in etc NixOS and called configuration.nix, which is the files that person have to edit. Unfortunately, we don't have graphical interface except image or VI. And you put all the configurations that you need for your system, like where the bootloader should be installed, what the file system you have to mount, the swap device that you want to use, devices. And in this case, we set the SSHD configuration. So here we have an attribute set with options that are defined. So as a user, you just edit this configuration file, add a new option which are described in a manual or in main page, and you just have to run one command to build your whole system. You just run this command and you say that you want to build the system, it will build the system, or you can switch, which will replace your current system by the new one. And when you have installed this new system, we have to activate it, because the symlink is not enough to make your configuration usable. We have to change path WD. We have to change some files which are required to be in /etc and not to be symlinks for security reasons. And as we saw, we inherit NixOS system for rollbacks. So as you saw in my menu, I have a lot of versions for coming back to previous configuration. So I will continue in this configuration, and I will describe a bit the syntax. In the syntax, you can say that you depend on other files that you want to embed their content. So here I have created a configuration for this room, and my configuration requires that I need this room. So I want to enable the server, yeah, that's work, and I want to use a small footprint window manager because it's a very old computer. So the syntax is that we have imported files and option definitions. This syntax is used for /etc configuration.nix, but you can use another syntax which works as well, where you define imports and option declaration and option definitions. We will go on option declarations. So I created a new module, which is an attribute set where I define the options, and I define that I want to attend the option to describe if I attend or not as the FOSDEM. So the default value for us is true. I define the type, which is a needs function. With the cursor one. And I give a useful description, which is not the case here. As types are defined in Nix, we can have multiple types, and we can use Nix language to define new ones. So we have Boolean, strings, and we can define how to handle environment variable and how to merge them, merge multiple definitions of an option. So if one person defines that he wants a path to be set to something, and another module defines the same path to be set to something else, we can decide how to merge them with a colon between them. We can use derivation or list of another type. Now we will see how to use these options. So here we are in the section for option definitions, and we define the SSHD enable in function of the configuration. So this argument represents the whole computer configuration. In this argument, you have everything about your computer. See, we have this feature from the laziness of the language. This argument is a merge of all modules, and which reproduce the syntax of modules. So this is the options that we have defined in another module, and we use its value from the whole computer configuration. In this case, we want to say that we want to disable SSAG if we attend the FOSDEM. And when I say these arguments merge all modules, this merge also this one. So this module is included in the whole configuration. So this introduces three key things which cause the Nix control flow to break. So if we want to check the value of this option, if we attend them, then we want to disable SSAG, otherwise we take other values. The problem here is that when you want to evaluate that you attend at the FOSDEM, you have to evaluate this, the argument, and when you evaluate the argument, you merge all modules. So you have to know what are the options defined in all modules, and then you can define the access to it. So to know all options defined, you have to evaluate all config in each module. So if we want to evaluate this one, we have to evaluate this if statement, and we have an infinite loop. And there is another problem, which is that enabled as a merge function, which take by default the true value we fold with a OR. So if someone else has, if another module defines that you want to enable SSAG, we can force it with only defining false. So we need to introduce control flows for modules. And to do that, I've introduced properties. Properties annotate definitions. So here you have a definition, and I want to say this definition is only valid if I have this function, which is a property, which will annotate the enable definition with the condition that I want to define this value only if I attend the FOSDEM. And I want to override other value with the 10 priority. So we annotate each definition, and when we evaluate configuration, we just take properties and we move them, we delay them until we can really execute them. So we can really execute them when we are at the equal here, when we are sure that there is no recursion unless the user made it. So we delay the if statement on the service, and when we go further on SSAG, and when we go again further on the enable definition. To express these properties, we have 4 base functions, which are on delay, which define how to item the property when we delay it. We have on global delay, which is the same thing, but with knowing what are other properties. We have on eval, which is used when we evaluate the value, and we have on global eval, which is used when we evaluate the value, but with the knowledge of other properties. And this allows us to define many properties. So this property is used to, and cannot def is used to define that we don't have a definition, which is not the same as an empty definition. For example, false is not the same as not defining false. We have the if statement as presented here. We have override, which allows us to decide which definition takes precedence or not. And we have ordering to order the multiple definitions. as definition can be spread around multiple modules. Now I will show you some real examples. So here is a simple example where we under time zone. That's only this module. We define an option with a default value. And as far as I know, there are not much users in America, so maybe we should change the default value. And we define the configuration and what we should add to the initial to the shell script initializer. So we want to add that we export the time zone, which is defined here, this option, and we want to say where to find the time zone information. So only by adding this module, your shell initialization will depend on the glibc. So when you use this module, this will install the glibc on your computer. Now we have the Xmonad window manager. So I've truncated some parts because unfortunately the file is a bit short. And this is the same, except that we have some shortcuts here. We have we define this attribute CFG to a shortcut to the Xmonad options, and we enable the configuration how to start the Xmonad window manager, and just by defining the enable flag of Xmonad, this will install the Xmonad window manager. So at this time of the presentation, we can reproduce most of the systems that you are used to have with Debian on other distribution. But we can do more than that. What we can do is express things with more abstraction. What you see here is generate configuration for this laptop. So if someone else, which is unlikely, has the same laptop as me, I already suggest him with defining a default value, which is just a shortcut over MK override, with a kernel which supports the SCPI, so it won't have a problem with the battery. I've already said what are the modules which are required to boot this laptop. I've already said the cable model, so you don't have to find out what you should define for this option. And the same for the touchpad, and the same for the video card. And also the same for the PCMCIA with a config option, which is quite different than what you can find on the web. So this small expression shows you that you can go. You can have a very useful abstraction compared to just installing packages and configuring Apache, configuring its work, or stuff like that. You can say that you want to have a configuration for your home network or for your cluster of computers with small differences between them. This gives you the abstractions that you want. You just have to write a module which is a really simple syntax and define what are the options that you want to define, and if you need it, you can declare options that are used by other modules. So with Nix we have package management which are with isolation, so we don't depend on other program. We have atomic upgrades, so we inherit that for NixOS. We have rollbacks that we'll inherit too. We have multi-users, which I haven't presented in this presentation, which allow you to build your system as a normal user, so you can do as a normal user NixOS 3 build. You can also build in a VM to test your configuration in a VM, and as a super user, you can just set it to boot or to switch it. And we can reproduce it, because if you just take the configuration file, you send your configuration file to somebody else, and you will be able to reproduce the same thing as you. Because we only use, we generate the configuration file, and we use a package manager which has explicit dependencies. So there is a link to nixos.org if you want to visit, or you must visit it. And if you have questions, I can answer some. Yeah.
I have a question. You said that the hash is computed from the files, from the scripts that build them, and so on. Would it be enough to compute just the hash from the resulting binary file?
The idea is that you know from the sources, from the build script, and from other stuff, is that you can predict what hash you could have. So the hash is computed from the sources, and you don't have to build it to determine the hash that you should have.
Oh, so you know the hash before the build?
Exactly.
Okay.
Any other questions? I've convinced so much people in one presentation. Okay, so let's continue with a small demo. There is only SH, which is a symlink to the need store, and damn, that's working as expected. Oh, that's not normal.
What's in there? User. You deleted /lib.
Oh, yeah. Ta-da! Still working.
What files do you have in the What files and directories do exist in the directory? Just etc and Nix?
Yes, we have /etc and /Nix, which are the bases, and /bin for sh. And in /etc we have a lot of symlinks.
Could you share us the contents of the root directory?
The contents of the root directory should contain my old configuration of Gen 2. Yes, root directory. Yes, you have procs, you have root, mnt, drive crash, and other stuff which comes from my previous systems. And the sources of Nix, which I store in this directory. So, let's see. So you can see that the /etc is most of symlinks, which are this should be these are static parts, for example, some things that are enabled by the activation script. And the static directory just a symlink to something else. In /etc NixOS, we have we have configuration.nix, we have an old version to Emacs, and we have some sources where I store my computer configuration, NixOS sources, and the list of packages. If we go into the sources, we should have a module directory, and this is an old version because I'm no longer using this computer. So we separate all modules inside a list of directories. And we have a lot of modules. So we have modules for the kernel, stage 1, for the X server, for Xmonad, for the window managers that I'm using, and not for this video projector. So we have a lot of modules for display manager, with the Slim Display Manager and KDM. So we have a lot of modules, and they are all merged to generate the whole computer configuration. And inside each module, you have access to the whole computer configuration. No questions?
Yep.
Yeah.
I was curious, what are your future intentions for NixOS?
There are some projects about license calculation to check that really the system is respect a license. Currently, that's only a project, an IDE and thoughts and some tools to manually check that you have the right license in your derivation by checking all packages from which it depends. So there are some words like that. There are others, I think.
I'd say that the main research direction is doing distributed deployment, so you can have specifications of networks of machines, and you can automatically deploy them to real machines or build virtual machines from them, or deploy them to the cloud, and it all happens magically from a very short specification of what all those machines are supposed to do.
So let me introduce Elko Nostra. Yeah.
There are ports also to other platforms.
Cross-build information.
Yes.
Yep.
At least we have a port to the Shiva plug for this, for the ARM platform, and NixOS manages U-boot and those things. And we have all those properties also in the Shiva plug. And Nix packages also has some kind of cross compilation to build this to build an NixOS system, or at least packages for another platform.
You can use the Nix package on regular Unity solutions as well, even on the BSD family.
Subwin also.
Yep.
Let's take the case of when a hacker would break into a NixOS system and modify files, some installed application files. Is there some kind of built-in safeguard for detecting corruption of files?
Yes. First, there is one thing, which is that all paths in the Nix store are read-only. So this will take time, of course.
But there is a command to verify that the contents of
yes.
the store path hasn't changed. So just like RPM -test verify, there is a command to check that this stuff hasn't changed.
So first, yes, all paths are all packages are read-only. So you can't have a user which is modifying this stuff, and normally this will not be used. That's because I
mentioned that there was one incident where NixOS machine was hacked But the rootkit that they uploaded failed because there is no /lib, so none of these ELF executables worked. Because there was no /lib LD Unix as well. So that's a unplanned advantage.
Yes.
Could you please type which fixed term in terminal?
Which one?
Which
Space.
External.
fixed term?
Yes. You have a list of profile which is incremented each time you install a new package. Generations. Yeah, I have tool generation. So the last one is my current generation. And the two previous generation are are coming from modification. For example, I either install or uninstall something. So you have generation. I don't have much, so I have garbage collected. And you can roll back to previous profile. Yes.
How would I copy of the trace for your computer?
Could you?
If I have the compressors area, IRC,
Oh.
and I know your computer works.
Yes, you can check out the repository. Okay. So, last thing to show. My name. This lullaby is the name of this file. As you can see, I just include the computer generic configuration. So you just have to do the same to use the configuration for PCMCIA and other stuff.
Well, you can even transfer binary packages efficiently to each other. So we use this hashing scheme, which is derived from all the inputs. Since we're using the purely functional model to derive such hashes, it doesn't matter on which machine you have built a component. So if I decide to transfer a particular component to somebody else, I can transfer that component with a hash code. We even have a dependency resolving mechanism that takes all dependencies into account. So when we want to transfer a particular component and all its dependencies, we just have to scan based on the hash code what dependencies are there, and then just transfer the missing part.
And it's for the video. It's okay.